here's what it looks like. You have an example right here. 5.59 times 10 to the 6th. That is in scientific notation. You see the format of scientific notation up here. A times 10 to the n. And I'm actually going to write this out a little bit differently. So the first number that you see should be between, oh, my stylus is not doing good today, between 1 and 10. And then it's going to be times 10 to a number, and that number needs to be a positive or negative whole number. So the exponent here, so we haven't completely forgotten exponents today. This guy has to be what we call an integer, which is a positive or negative whole number. So the first one, usually the first number is going to be a decimal, but the exponent cannot be. Okay. Looking at example 1, you have 5.59 times 10 to the 6th. What the 6 tells you is to move the decimal place 6 places to the right. And so when we're looking at the exponent, it tells us how to move the decimal and how many times. So in general, so the exponent, if it's positive, it goes to the right. If it's negative, it's going to go to the left when we're moving it into standard form. If we're moving into scientific notation, then we move the decimal until the number's between 1 and 10, and then we have to figure out if our decimal is going to be, exponent is going to be positive or negative. It's easiest to do this with examples. Let's read this little paragraph and then we'll get started with that. When a measurement is in scientific notation, all the digits of the number between 1 and 10 are significant digits, meaning not zeros. When you multiply or divide measurements, your answer should have as many significant digits as the least number of significant digits in any of the numbers involved. So basically, if you see numbers that aren't zeros, you're going to keep those, and then once it just starts going 0, 0, 0, 0, 0, you can forget about those. This will make sense when we do it. First, determine if the numbers below are written in scientific notation. Let's look at the first one. 45 times 10 to the 5th. Remember, we want the first number to be between 1 and 10, and we want the exponent to be an integer. So discuss with your partner, is that in scientific notation? Bingo. No! Because of this. I'm just going to circle it. 45, not between 1 and 10. Next one. 2 and 35 times 10 to the negative 4th power. Discuss. Yep. 2.35 is between 1 and 10, negative 4. It's a negative integer, or it's a negative whole number, and so it is an integer. Next one. 10 and 7/10 times 10 to the 8th. Discuss. Okay, please tell me, is it in scientific notation?
No, it is not, because 10.7 is not less than 10.
Great. It's greater than, right?
But
Scientific notation.
Yes.
And Stevie, how do you know?
Because the first number is in between 1 and 10.
And then the exponent?
Is it an integer?
Yes, it is. Okay. Each number in scientific notation. So we're looking at this number. It's a fairly large number, but regardless, we can write it in scientific notation. And so what we're going to do is we're going to find our decimal. Right now, you don't see it. Could someone help me out? Where? Raise your hand. Where is the decimal right now? Xander?
After 6.
Right. Right there. So you don't see the decimal, but it's there. And so we're going to move the decimal until the number is between 1 and 10 when we read it from left to right. So I'm going to start here, and we're going to go. I'm going to keep going till it's between 1 and 10. 23.0. Am I there?
No.
No. Keep going. 2.3. Am I there?
Yeah.
Okay, I'm going to draw a little arrow to show that I moved it to the left. And so now we're going to rewrite it. I'm going to go ahead and round this one. But you could leave it like this, because technically those are all significant. No, I'll just leave it like that today. Sure, why not? Okay. And we're going to do times 10 to the however many times we moved the decimal. So let's count the little mounds here. 1, 2, 3, 4, 5, 6, 7. So it is times 10 to the 7th. To figure out, listen up, especially if you've never seen this before. To figure out whether it should be positive or negative, you could think about two things. Generally, if it's a big number to start, it is going to have a big exponent. It is going to have a positive exponent. You could also think, okay, right now it's at 2.3. If I had to move the decimal back, I have to go back to the right. And so if I want it to move to the right, then it has to be positive exponent. Okay, so little number, negative exponent, big number, positive exponent, or think about the direction you would have to move it back. Next one, again, move the decimal until it's between 1 and 10. It is not. The decimal is way out here in front. And so we're going to move it until it gets to the actual significant digits, because you got a bunch of zeros, and those don't matter. So we're going to start moving our decimal to the right, because that's where all the other numbers are. That's where the part is at. Keep going. Okay, let's start checking it. 0.457. No, keep going. 4.57. Yes. Stop. Don't go any further. Now, remember, you are reading from left to right. I see some students who keep moving it, and they're like, well, 7.54. No. While I understand that number is between 1 and 10, you have to read it from left to right. That's how we read numbers. So it is 4.57. This is where we talk about the significant digits. The zeros out in front are not significant. Forget about them. 4.57 times 10, and we count how many times we moved. So let's count the little mounds. You're not counting these, like when they goes in between the numbers, you're counting like the valleys, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Now, we have to decide if it's positive 10 or negative 10. Guys, was it a really big number to start or a really small number? Small, so it should be negative. Another thing you can think about whenever people are ready is if you had to move that decimal back to where it started, which way would you have to go? Left. And if you look back at what we said at the top, if the integer is negative, it moves it to the left. And so since it's a small number to start, and since I would have to move it back to the left, it's got to be negative 10. Right? Now let's talk about standard form. So standard form is the form with all the zeros. So if there's still really big numbers, standard form does not have the times 10 to the exponent part. Write each number in standard form. So we're going to move the decimal back to where it started. Put it in the drawer. So that we probably have some zeros. So I'm going to rewrite my number, 2 13/100ths. Let's look at our exponent. It's positive 5. Could you guys please point left or right? Which direction will that move? The decimal. Look at what we said on the top. Which way does positive move it? It moves it to the right. And so we're going to move the decimal 5 times to the right. So we start here, in between 2 and 1, and 5 times to the right. And you should probably show the little valleys. This is how you don't make mistakes. 1, 2, 3, 4, 5 to the right. And then make a little note out to the side maybe to fill the empty spots with zeros. So right here, you have 1, 2, 3 empty spots. Do not replace 1 and 3 with zeros. They live there in that valley. Don't kick them out. It's their house, okay? That would be really mean. So you get the 1 and 3 get to stay, but the empty spots get zeros because something has to go there. And then lastly, you should rewrite the number with the decimal moved. Since it's at the end and this is a bigger number, I'm not going to actually put the decimal, but I will put a comma because it's in standard form now. So we moved it to the right, which is why it's helpful to actually put the arrow so you know where the decimal started and ended. One more. 9.65 times 10 to the negative 4. Point which direction the decimal should move, please. Everyone participate honestly. Yes, you move it 4 places to the left. And so we are going to put the decimal there and then move it 4 places. Oh, you know what? Actually, I should rewrite it before I do that. One, 2, 3, 4. Show the work. Draw a little arrow so you know which way you moved it. And then fill the empty spots with zeros. 1, 2, 3 zeros. And rewrite it with the decimal in the correct place. That's important. 0.00965. So 9.65 times 10 to the negative 4 is the same thing as this number in standard form. Yeah, right now your decimal's over here. So we're going to move it till it's between 1 and 10. Okay, I'm going to start moving it, guys. Tell me when to stop. Oh, that's not right. See what I did? 1, 2, 3. Between the 0. There we go. 93.0?
Wrong.
Bad.
Yeah, wrong.
9.3 is where you want to be. So 9.3, that's the significant digits. All the zeros are not significant. They're going to be documented. We put the exponent times 10 to the, count guys, on your own, decide what the exponent should be. What is it? It is 7. Positive, let's check, positive or negative? Okay, let's think about it. It was a big number to start. We talked about big numbers get positive exponents. Also, if you were to move that decimal between 9.3, if you were to move it back, it would have to go to the right. And if you want to move a decimal to the right, does it have to be positive or negative? Positive. And so it has to be positive. Okay, that one's done. Last 2 things. If you multiply, go ahead and do this. If you multiply 225,000 and 2 million in your graphing calculator and press enter, you'll get 4.5 E11. Would you type that in, see it on your screen?
Times 10 to the 11.
Yeah, exactly. That is spoken mathematically correct. That's even more impressive. 4.5 times 10 to the 11. So the E means times 10 because in your calculator, it can't very easily do the times 10 to then raise it to a power part. So to keep it all in one line, you use the E instead. Not my idea. I don't really know why. But that's what you're going to see in your calculator when you're using scientific notation. Last one, go ahead and divide 0.5 by 2 million in your graphing calculator. Press enter. You should get 2.5 E negative 7. And then we will discuss what that means. Owen, what do you think that means?
10. E means 10.
E means a 10. So what would the entire thing mean?
2.5 times 10 to the negative 7.
Right.